All right, in this video, I'm going to take a couple of the skills that I've been showing and put them together to do something, sort of a synthesis of different skills. And so I have a basic setup that I pretty much always use: a time parameter to forward the simulation, an equation of motion with some domain restrictions to make sure that the equation is only valid for times between 0 and the current time of the simulation. And then basically we just calculate the position of the particle at the time of the simulation and then plot it as a point. Something that I've shown in other videos how to do is how to make a motion diagram. And when I showed you how to do that, what you want to do is define some new times, times that include equal intervals of times up to 1, from 0 up until the current time of the simulation. And so if the current time of the simulation is 0, this is only 0, but as we move forward in time, this array gets populated with more and more times, like 1, 2, and 3, and 4, and 5. So then what you then want to do is calculate the position for all those times by plugging in calculating the position of the particle, not at the time of the simulation, but all of these times that are equally spaced, and store that in a variable xm. And then what we can do is then plot that here. And this is all stuff that I've shown you before. What I want to do now is sort of just play that for a moment. I'm going to close these folders. And sort of it does the standard thing that I've showed you. Sometimes, I kind of like to make the motion diagrams things be sort of dots like that. And so that's one skill I showed you how to do, which is how to make a motion diagram. The other skill that I've shown you is how to make a label. And you can hear when I click label, what ends up happening is it tells me where these points are, but that's actually not what I'm interested in. I'm going to do a little bit of work to better organize this so it's always shown below, and I'll make them small. I don't want this to show the points in a mathematical sense. I want them to show me what time that particular dot was made. And so what I can do is use the $sign, squiggly bracket, and then all I need to do is put in the T subscript M notation there. And what that does is that creates a label for each of the times that happened. I'm going to put a second after this. And so then what you can see is as that happens, it will label those with the times that they occurred, which is kind of neat. Anyways, this is just a quick video to show you a synthesis of 2 skills, sort of making a motion diagram using an array of times, and then using labels to sort of quantify aspects of that motion diagram.